leaders solves. So this is an actual problem that Mrs. Abruzzo and Mrs. Meyer came up with. Since Mrs. Meyer's our basketball coach, they did a real wonderful job on this problem. It's a real life problem. Okay, it says you are playing basketball in a European league, so we're gonna have to use the metric coefficient, right? We're not going to use the -16. We're going to use the -9.8. You release the ball at a height of 1.9 meters, which is about how many feet for those people that aren't familiar with metrics and have to think of feet? Careful. 1 meter is about 3 feet. Okay. So, yeah, we're talking about a person being about 6 feet tall. Okay. So the ball is at a height, it's released at a height at 1.9 meters with an initial velocity of 8.1 meters. So if we multiply that by three, it looks like 24 feet per second, right? 24, 25 feet per second. How many seconds until it reaches the rim, which is about 3 meters high? So again, we're talking about 9 feet. That's about what a basketball rim is at, right? All right, I'm going to draw a picture because I like pictures, right? I'm going to draw a picture first, then go back and pick up the model, come up with the model. All right, so I'm going to emphasize that first quadrant. Okay, so there's my y-axis, my x-axis, and I was really good about drawing a picture last hour, but my video recorder wasn't recording, so now I'm going to probably draw a terrible picture. So instead of my y-axis, I call this the height, the h-axis. Instead of the x-axis, I call this my t-axis for time. All right, so we start at an initial height here of 1.9 meters, about 6 feet tall person, right? So 1.9 meters. And they're throwing this basketball up at about 24 feet per second or 8.1 meters per second. And it's going towards a basketball rim, right? Here we go. You're going to see Mr. D's artwork here. There's my basketball pole. And I need a backboard, right? Well, maybe I'll do a different color for the backboard. There's my backboard. And I need a rim. Wow, this is fascinating. There's my rim. There's my basket. My netting. Wow. That's impressive for a math teacher. Again, no laughter. So it keeps going, and then it's going to go towards this rim, and then boom, hits the rim. Okay, so right about here is my vertex, it looks like, right? And my vertex, remember, is T comma H. That's a pretty good picture. I think you guys should congratulate me on your way out. Thank you, Doug. Thank you very much. See, somebody appreciates my artwork. Thank you. Thank you. All right, so my equation here. Let's go back to our equation. Now, remember, I'm going to use -9.8 because we're dealing with metrics. T squared plus b sub 0 t plus h of 0, or h naught, however you want to say it. Let's go back in and plug what we have. Okay, I already told you about the initial height here of 1.9. So here's my initial height, right? So 1.9 is my initial height. And what else do I have here? Well, they even said it. Initial velocity, 8.1 meters per second. So my V sub 0 is 8.1 meters per second. And I'm going to go ahead, I need to keep this coefficient, that's gravity. So let's see, negative 9.8 t squared. Now, they give us the height, but we're not going to really need it for this problem because we've been putting this in the calculator, right? Our initial height is 3.05, but we're going to use the y equals key anyway, right? So we really don't need to put that 3.05 in there. If we were to do this manually, we would need that 3.05, algebraically, I should say. All right, I have everything I need, right? Now the fun begins. Wow. Are you guys tired? It's only
Always.
Tuesday. It's only Tuesday.
Yeah. Work.
All right, so on your calculators, let's start from scratch here. Let's get everything defaulted back to zero, okay? Then I want to hit your y equals, clear anything out of there. Hit clear. Why don't you go to your zoom key here? Let's default everything back to, negative 10 to 10 for the y-axis, min max. Same with the x. And so I'm going to go down to my zoom key, hit zoom standard, hit enter. It's going to default back to my original graphing Cartesian plane. All right, I'm going to go ahead and put my equation in there now. Unless you want to do it algebraically, by all means, go ahead and do it. So I got negative 98t squared. So I'm going to hit my y equals. Again, use your minus, not the minus sign, your negative sign. If you use a minus sign, you're going to get a syntax error. So you got to use the minus key, the negative key. Did it again. Negative 9.8. 9.8. And I'm going to use the X button for the t squared because if you use a t, it really messes things up. So I'm going to use the X, going to put in an X there. There's the X key. And my squared key is right here. So there's my negative 9.8 x squared plus 8.1. Again, I'm going to use my X key. I'm going to use X, which is right there. Hit X plus 1.9. Then I'm going to graph it. And I should get opening downward parabola, right? Because the minus sign there. So I'm going to hit graph. And there's my parabola. Now, I want to focus mostly on this first quadrant because that's where the action's happening in my word problem, right? So I'm going to play with my window a little bit. Now, if I make a mistake, I can always go back to my zoom key and hit zoom standard. So don't worry about making a mistake. So I'm going to go to my window here. I'm going to try to focus, get into more focus of this quadrant one. So maybe I don't need to go up to 10. In fact, I know I don't need to go to negative 10 on my y-axis, right? So I'm going to start there. My y max, now remember this is 9 feet, so it looked like it was only half of that. So maybe I'll put a 6 here for my y max. Again, I don't need any of this 3 or 4 quadrant. I need very little of it. So maybe I'll put a -2 there. Make sure you delete that 0. Okay, so I'm going to focus more on the y here. Same with the x. I only need a little bit of negative number for the x, right? So maybe my x minimum, I'll do the same thing. Do a -2. Delete that 0. And I'm just gonna maybe I don't need so much 10. Maybe I'll just go, oh, I don't know, maybe I'll do 6 here too. So I'm gonna go ahead and graph it and see where I'm at. Well, that's pretty good. Gets me a more zoomed in picture of my parabola. All right, so I need my vertex for this because I'm looking for, it looks like how many seconds it reaches that point. So I'm going to need this time in here where it reaches that height, right? So I need that vertex coordinates. So this is a maximum because it's opening down. I'm going to have the calculator calculate it for me so I don't have to do it algebraically. So I'm going to hit my second key and my trace button because that brings up the calculate menu. And then I want the maximum because it's opening down. So I'm going to use my arrow keys here and go to number 4, maximum. And I'm going to hit enter. Now, it's asking me, get to the left of that vertex point. Well, I'm looking on this and I'm like, well, heck, where's my cursor? And my cursor right now, I'm going to zoom in on this, okay? My cursor right now is sitting at x equal 2 comma -21. So my cursor's at 2 -21 way down here. Okay, I'm going to bring that cursor closer to x equal 1. So I'm going to use, let's see, my left arrow key to get that x to closer to 1. Do you see how it's going down every time I press that left arrow key? I want to get it to closer to 1. Once it gets close to 1, I should see it. There it is. Okay. I'm going to be careful here. It's asking for left bound. So here's my vertex. I need to be to the left of that vertex. So I'm going to keep going here. I'm using my left arrow key to bring that cursor to the left of that vertex, that maximum point. And I'm finally there. So anywhere to the left. Okay. Now I'm going to hit my enter key. And it's going to put a line for that left bound. All right, now it's asking for a right bound. So now I got to get my cursor to the right of that point, that maximum point. So I'm going to use my right arrow key to bring that cursor to the right of the vertex. Anywhere to the right is fine. I'm going to put my right bound line there by hitting enter. So my calculator now is going to calculate the vertex, the turning point between those bound lines. Okay. And it's asking, well, should I guess where that point is? Hit enter. By saying yes, you hit enter. And it tells me that vertex is at the point 0.41.
Like several people sleeping, playing on their phones, playing on their Chromebooks.
0.41 comma 3.57. That's my vertex. Yeah, don't forget we're having a quiz on this Friday. So pay attention, guys. I'm going to zoom back out a little bit here. So there's my vertex. Remember, This is my t time. This is my k, or I'm sorry, my h height. So we're looking for how many seconds to reach the maximum, the height, not the maximum height, 0.41. So 0.41 seconds. Actually, that is maximum height for this parabola. So I went a little slower than I did yesterday. Hopefully, kind of cleared up how to do left bound, right bound issues. Are we good? All right, number 4. We don't necessarily need application problems, word problems. We can do area problems or other quadratic problems, um, like areas of figures, and by using the graphing quadratic models. All right, let's do number 4. It says here the area of a rectangle shown below is 105 meters squared. Find the x and the dimensions of the rectangles. What's the formula for area of a rectangle? Length times width, right? Geometry uses base times height. Okay, either way, doesn't matter to me. I'm going to call this my length, call this my width. So my area is going to equal my length, which is, I got two terms, so I better put it in parentheses. 2x plus 1 times my width, which is x. In fact, they even give us what the area is. It's 105. So 105 equals, I'm going to put the x first because I'm used to having x in front of parentheses. And I can do that because it's commutative, right? Distribute the x. So I have 105 equals 2x squared plus x. Now, in order for us to graph or find the roots of this parabola, I need my y to be 0. So I'm going to subtract 105 from both sides. So I get 0 equals 2x squared plus x minus 105. Now, there's a couple different ways we could have done this problem. In fact, you could even find what the roots are, the solution, by factoring this, which is what I made my second hour do. They weren't happy about that. But since we're doing quadratic modeling, we could put this parabola in our calculator, right? And find out what x is. So I'm going to go ahead and put in my handy dandy calculator here. I'm going to clear that out. I'm going to go to my Zoom standard, get back to my default graph, and put in, let's see, I got 2x squared, 2x squared plus x minus 105. I'm going to graph it. I know it's opening up because my 2 is positive. And I'm going to get this whole thing fitted on my window. So I know I got a pretty negative 105 here. So my y minimum, I'm going to change my y minimum. See, I need at least 105. So maybe I'll go 120. Hit graph. And there I have my parabola. I can easily see it now. Now, notice that my y is 0 here, right? When my y is 0, I'm looking for my x. That's my x-intercept. It's either this point here or this point here, right? My x-intercepts. Well, I know it's not this point because that's negative, and we're dealing with a dimension. So I need to find the value of this x because the y value is 0. Now you could cheat and go to the chart, but we'll use the left bound, right bound thing since we need practice with that. So I'm going to go to calculate again. Hit second trace. This time I'm looking for the 0. I'm going to highlight 0, hit enter. Now I don't know where my cursor. Oh, there it is, right there. It's at x equals 0. So I need to be to the left of that point, which I am. I'm just going to get a little closer. Stay to the left of there. Enter. Now I need to be to the right of it, or really I need to cross the x-axis here. Hit enter for the right bound, and then it's asking me to guess. Hit enter for yes, and my x-intercept is 7. And again, I could have cheated by going to the chart and looking for a y value of 0, which is right there. Therefore, I know that my x-intercept is 0. This happens pretty rarely, but I'm not done yet, right? It's asking me for the dimensions. Well, my width is easy. That's 7, let's see, meters. My length, I have to substitute in 7 for my x. 2 times 7 plus 1, which is 15 meters. Questions, comments, concerns? And that completes the notes for quadratic modeling.